I'm going to run through an example of modeling the equation of a sinusoidal function. You can do this from a word problem, you can do this from a graph. This, of course, is going to be an example where I'm using a graph. Our book uses equations of the form y equals, they use a c as the constant value plus the amplitude times sine of, our book actually uses sine of b times x minus d. I believe in the book that most of you used, they used a value called k right here. And basically the formula that we're going to be using, this of course is the vertical shift. This is the amplitude. That's basically the multiplier for the period, or technically the horizontal compression, depending on how you want to look at it. And then meanwhile, this d value there is basically going to be the value for the phase shift. And those are the things that we want to consider when we're looking at an equation. Now, with that said, I think it's relatively easy if you're careful to go through the problem. And if you've got a word problem, try to plot some points. If you can get an idea of what your curve looks like, it's going to be very easy to go through this process. So the first two things that I look at, I try to identify where the axis is. How has this graph been moved up or moved down? Because I need to decide if it's going to be a sine or cosine function. And of course, it can be written in either form. You just have to decide how you want to do that. So two things. First of all, I notice that this graph goes from -1 all the way up to 5. Okay, so this thing has a height of 5 minus -1. This whole thing has a height of 6. Okay, keep in mind that the amplitude is how far it goes above or below that horizontal axis. So that's going to be half of 6. So I usually keep a list of the key information. So the amplitude is going to be 6 divided by 2, which of course is 3. Okay, so I have that value here that I can fill into my equation. All right? And I think that's really important because if you can draw in that horizontal axis, it's going to help you orient everything about what's happening. So I have a horizontal axis running through, notice that this goes from -1, amplitude is 3, so the amplitude is going to lead me to have a horizontal axis that's running through 2. In other words, halfway between the -1 and the 5. And you can average the maximum and minimum values of your function. The average of positive 5 and -1 is going to be 2, and that tells you your vertical shift. So second of all, my vertical shift is +2. Okay, and again, I may want to fill that in here. That constant value there is going to be 2. And I can continue with the process. Now, once you've got your axis in, you're going to be able to identify kind of a starting point and an ending point for what you want. I look for something that's either starting at the top of a curve or something that's starting along the axis. And I notice this point right here. I can think of that as being kind of the beginning point for a sine function because it's starting on the axis as opposed to starting at the maximum value or the minimum value. So I'm going to act like I'm starting right here. And basically I want to follow my curve and I want to figure out what the period is. I want to find out how many how far it needs to go through one complete cycle. So it starts out here, goes down, comes back up, and right here is where that starts over. Okay, so if I want to find the period goes from pi over 2 to 3 pi over 2. So 3 pi over 2 minus pi over 2, of course that's just 2 pi over 2, which is really just pi. So the period is pi. Okay, the normal period of the sine function or the cosine function is 2 pi. So you can kind of gut instinct your way through that as far as what this k value needs to be. With that said, I prefer to use the formula that you can find the period by taking 2 pi divided by the k value. Okay, we know in this case that we want that period value to be pi. So what is k going to need to be to, so basically I want to take 2 pi divided by the k value. I want to get pi. Well, I can cross multiply here. I get k times pi is equal to 2 pi. we find out in this case that k is going to be equal to 2. And that should make sense, because basically if my period is going to be half as big, that means that I need to be multiplying by 2 to have my graph moving twice as quickly. Okay, so that k value is 2. Okay, and again, I can't stress it enough. You need to know that the period is always 2 pi divided by that k value. So you're not putting the length of the period in that position, you're finding the constant value that results in that period based off that original 2 pi for the original sine function. Okay, very, very easy to make that mistake. Okay, so 2 pi over k equals the period, and then you set it equal to however long it takes it for it to cycle. That's how you're going to find that k value. Okay, again, you're going to be stuck in a lot of these circumstances, especially if they don't give you a pi or something like that in there. Okay, finally, the phase shift goes in the opposite direction. So for example, if it's +3, the graph gets moved 3 to the left. If it's -3, it gets moved 3 to the right. And in this case, you can see where the graph starts. Sine starts at the origin. This is that point along the axis. And you can see it's been shifted forward pi over 2, which means that our phase shift is going to be technically pi over 2, but notice it's x minus that value. So that's going to be x minus pi over 2. And now you can fill this out. Final equation here is going to be y equals 2 plus 3 sine of 2 times the quantity x minus pi. So again, terribly complicated looking equation, relatively complicated looking graph. I really don't think the process is that bad though. If you think in terms of, find the amplitude and figure out where that horizontal axis is based on where your vertical shift is, use the formula for your period, and then you should be able to go back and look at everything and figure out what your phase shift is. These problems really can be extremely doable.